Hello everyone and welcome. My name is Peter Schaknat. I am the Managing Director of Schaknat Electronic GmbH, and today we are going to be optimizing a Scania R580. So, very briefly about today's process. This particular vehicle is a Scania R580 DC16, which features a V8 engine with two-stage exhaust gas recirculation, a variable turbocharger, a 16.4-liter displacement, and an impressive 3,000 Newton meters of torque. It also has an OptiCruise gearbox, specifically the OPC5 version, and it's still equipped with a clutch pedal for starting off. Now, the customer came to us with the initial request to have our app included, but he also expressed that he wants a special tuning specifically for the power version. What he wants is a performance variant that delivers between 750 and 800 horsepower. As a standard procedure, with our typical power optimization on these trucks, we usually add about 120 additional horsepower, so you would end up somewhere around the 700 horsepower mark. But in this case, the customer simply wants a bit more than that. And as you may already know, we can program basically anything, we can measure absolutely everything, and we can fine-tune it all specifically for you. Now, something very important with the gearbox, with the OPC5 system, is that you can basically also individually adapt the gearbox's behavior, which is especially important when you have the clutch pedal for starting off. For instance, you can also look at how it shifts through the gears, or for another example, when you approach a traffic light and it needs to downshift, we can adjust that behavior once again. This particular truck covers quite a lot of distance on the road, so of course long-term durability is very important. Of course, we don't want to push the mechanical durability to its absolute limits, but I would say that the engine is available from the factory up to 730 horsepower with the exact same displacement, basically the 16.4 liters. It just has different fuel injectors and a different turbocharger installed, so that tells us we still have the best possible conditions to work with. Cool. As some of you may know from a previous video, we've even made over 1000 horsepower, so theoretically speaking, with this particular engine, 900 horsepower would be easily possible with all the right settings. But of course, achieving 750 to 800 horsepower is already a truly massive amount of power for a truck like this. So today we'll be measuring on the dyno as we usually do, first measuring the baseline power, then we'll take a look at the basic data and see how the engine management is set up, and from there we'll build on that foundation. Now, I don't know if we'll be able to show every single measurement, because tuning means, that can ultimately mean we need to take 5, 6, 7 or even 8 consecutive measurements before we are completely satisfied that we have stable and repeatable values. At the very end of the process, I always make a point to go and lock the cars again. I perform a final check on all the critical parameters. I look at the exhaust gases to ensure clean combustion. I look at the boost pressure to see if the turbo is responding as commanded. I look at the fuel injection data, the lambda correction values, and absolutely everything else that is fundamentally important for the truck's long-term health. We need to be certain that it will still run cleanly throughout the entire rev range, that the engine does not start to run rough or hesitate because it is already trying to adjust somewhere near its limits. The goal is a vehicle that is really perfectly tuned, really cleanly and precisely tuned to the new power level, just as it is currently tensioned on the dyno. We have already tensioned it at the front in four-wheel drive mode. You can see that today the weather is extremely hot again, so for tuning, something like that is not really optimal. The reason is because I can physically feel the temperatures, and the ambient outside temperature also plays a very big role in performance. Of course, the test bench calculates correction factors for this, and that's all good, but it is always nicer to tune with a little bit cooler air. For me personally, the sweating is not as heavy, and of course, it is always a little bit better for the engine when we have lower ambient temperatures. Here again, you can clearly see that the rear of the truck is tensioned down, here again with the powerful hydraulic cylinder, just like the one below. It is tensioned again from the axle body and wrapped around with a chain rated for 5 tons of force. This is critically important because we are measuring such an incredibly high torque that we must have absolutely no slippage. The tire must not get too hot because otherwise it will begin to spin on the roller. If it gets too warm, it will lose its grip, giving us an inaccurate reading. So we are now just about to look at the input power measurement. Then when I go to the app, we will flash the final tune at the end. However, for the development process, I will use my Genius tool for the tuning. This is so that I can change the data sets much more quickly, allowing me to switch back and forth between different versions more rapidly. We can look at the measurements on the personal computer from time to time, but we will not be filming every single measurement run, because then the video would simply become far too long. So then I would say let us perform the initial input measurement, and then we will see our results on the screen again. We have now successfully completed the input measurement. I will show you the diagram very briefly. This is a used Euro 6 truck with some kilometers on it, so it's a Euro 6 engine control unit in its standard series configuration. You can see it down here again on the graph. The speeds from 800 to 2200 revolutions per minute. Here is the torque axis, and here again is the power axis. You can see up here again the power that we measured. The peak power is brutal, so I really have to say, for a truck with these kilometers, it's impressive. It's making almost exactly 580 horsepower. It should have originally had 3000 Newton meters, and as you can see, you have a maximum torque of 3076. So it even has 76 Newton meters more than the factory specification. Of course, this is thanks to the variable turbocharger. A lot of people complain about it, but the variable turbocharger provides a great torque curve because it pushes in a completely different type of air volume at the bottom of the rev range. So that is really, really good. We will now try not to make the maximum torque too high down here. The Scania has a limit of 3,500 Newton meters on the gearbox, so that can be easily justified. And I will now look up here at the top end, so that when we let the torque increase here, we shape the peak power to torque curve so that we pull it up higher. This is so that we can reach our target of 750 to 800 horsepower. In terms of maximum torque, we will have to see where we actually end up. The original value is 3076. You know yourself, if you now have 3,500, 3,600 or 3,700 Newton meters, those are quite powerful torque figures. The newest models have 3,700, so we are really moving into the upper class of performance. The customer drives a dump truck, so for mountainous regions he simply wants and needs the power. That is why we will make the eco optimization, which is the standard, to about 100 horsepower more, so 680 total, and then the full power optimization we will then individually add on top of that. So I will now go with the Genius tool, I will flash it, I will reprogram it, and then we will go and take the next series of measurements. I will now read out the original software with the Genius. It is with the Scania here, with the old Streamline model. They have the OBD plug located here, but as you can see, the connections are very familiar, so typically there are no problems. The plugs are pretty messed up from use, so that is why we are going in here now. I always prefer to pull them out at the back. It is much easier to get to them that way. Then you can read it out better. Then we go directly to the top of the connector. You always have to double check that the contact is correct, so I press the contacts once to ensure a good connection. I will now read out the file. As usual, we choose Scania on the device. You know this is the Genius tool. I always use it for development because we can change the dataset so quickly. I can save a few different datasets straight away and can even delete them directly from the device's icon. For this truck, I select this one, the EMS S8 XPI. XPI is what they call the common rail system. I think most people would not know how to identify it just by looking. Well, I will pull the data out now. We will go to the laptop and maybe I can show you a torque curve on the software as a brief explanation. After that, we will go back. We will flash the control unit again with the first modification. I will then take a few measurements, one after the other, and then we will see each other again for the final measurement on the main screen. Then I will explain it to you in more detail. But I will show you this first part briefly on the laptop, then we will get back to the topic of tuning. When we do a standard optimization, we actually do not need to change anything at all in terms of injection times, injection quantities, or rail pressure, since we are still operating well within the series range of the hardware. I will tell you that these are similar to what the manufacturers also use as prefabricated maps for different power variants. If we now want to go beyond that target, we must of course raise other maps as well. This is because the axis of the maps often only calculate up to a certain injection quantity or a certain torque value. We then have to change that, extending the axis to calculate the torque further. We do this so that we get a clean and proper result, and so that we are not just tricking the control unit, but ensuring that it really calculates the new values within the control unit, just as the manufacturer does. Very briefly, I am just going to show you a torque limiter map here. People who understand tuning can really do a lot with this. I have already set it up here. You can see the torque curve represented in this map. You can see the engine speeds again down here at the bottom. We have 800, 900, 1000, 1100 and so on, up to 1350 RPM. You can see here that the engine has its maximum torque between 1000 and 1350 RPM, and then it slowly starts to drop off. That is pretty much what we saw on the test bench in the torque curve. So you can see, just as it is shown here, that's exactly what the test bench always shows in reality. As you can clearly see with this Scania example, if we take a closer look at it here represented in binary numbers, the individual engine speeds are plotted up here on the axis. And over here we have the corresponding individual torque values. Now Scania programs the torque in milligrams per stroke, which essentially means the specific quantity of fuel being injected, just to explain the concept in a simple way. So you can see that when it's at its maximum torque, which occurs at 1003 revolutions per minute, it has a value of 342.5 milligrams per stroke. Now, as a point of comparison, if I were to take a look at a stock map, we could certainly use the injection quantities found there as a good starting reference point. So somewhere around 400, 420 or 450 should show up there. We'll take a look at that now and compare the values as well. Of course, it's very important that you can't forget that they have different fuel injectors and also a completely different turbocharger. So for that reason, you can't compare it completely, but we always base our improved and better tuning specifically on the original factory setup. Naturally, I make absolutely sure not to overshoot the mark, so I always gather much larger data sets and just carefully observe how things change. Basically, the process is like this. If I come here now and say, for example, look, I want to go from 800 revolutions per minute up to 2100 revolutions per minute. We want to have the torque there, so let's just put a few shells at 25 here, just to demonstrate it. Then I set the curve here, basically making it higher, and now I can individually adjust it again for the customer's needs. Alright, let's look here at this specific RPM where we'll make an adjustment to increase the torque slightly. You can see we're at the 900 RPM mark, and I have the ability to adjust this value individually. Regarding the pure value, it's possible to go up to a 30% increase, which translates to an additional 85 milligrams of fuel per stroke. Many women often come to me and say, yes, looking at the curve, what exactly causes such a strange bend in the graph? Well, for this particular vehicle, it's important to note that we have also adjusted the gearbox a little bit. So you should really orient yourself a little bit on the new curve that we've successfully generated. Of course, I do have to admit, I see some manufacturers where the cornering characteristic looks like a complete and utter disaster. And we sometimes have to ask ourselves the question, why on earth do you program it in a way like that? Or, to be perfectly honest, I don't know the exact reason for their choices, so if we then go in and adjust it properly, the cars also run completely and totally differently on the road, which is, of course, the desired outcome. So, as you can see right here, we can do this on a completely individual basis, because in this specific case, the customer wants to achieve peak performance way up here at the very top end of the rev range. It is also critically important that the torque is maintained for a long time over a wide range of engine speeds. So you can clearly see the maximum torque has been held for a lot longer here in this new map. We are now injecting 93 milligrams more fuel per stroke, which is a significant increase. So this right here is the original value for comparison. Let's take a quick look at the text file again, because it's always easier to see the raw numbers on the screen. Here we have an original value of 303 milligrams per stroke, and now after our adjustments we have achieved almost 400 milligrams per stroke. So you can see that's what it looks like in its binary form, and as I said before, in the display you can see the curve more and more clearly. So I can program this freely. However, if I program the curve here for the torque, I will still inevitably reach the limiter at some point, and that is always the crucial thing to remember in this process. That's precisely why you actually and mainly need a dynamometer, a proper test bench to test certain limiters, like the fuel limiters, the boost pressure limiters, and the torque limiters. To really get the absolute most out of the engine, it's incredibly important to have the test bench available for this kind of detailed work. So, you see, changing the torque up to a certain level is enough in principle, but if you want to go beyond what the manufacturer says, you have to be very careful. Here the system limits it again internally, then it becomes important to change more things in the software. That's why a job like this is not just done in 5 minutes, but a tuning session like this can really mean that I have to measure 10, 15, or even 20 times until I get the right value where I really want it to be. Some corner values are more on the upside, some more on the downside, but as I've already said, you can always adjust it individually for the customer and their specific needs. And you can see, yes, and I'll be clear about this, it's a bit of our trade secret, so I won't give away every single detail here. The torque curve, you can look at that, that's no problem at all, but we'll adjust the other things individually now, because finding these limiters, well, we've been struggling for weeks sometimes to locate them, and they can't. Once you've got it, you know where it is, then it's easy, but until you get there, HAL is a bit of a trade secret. I'm going to finish a few versions now, flash them onto the ECU, and we'll just do an initial measurement and then look at the individual measurements on the test bench again. So you can see it's just important for your understanding. With this limiter, it's always this particular issue. If I increase the torque here and run into a limit, the opposite actually happens. You can always see this on the brake stand. The power runs up, the torque limits it, then the curve goes down, and only then does it increase again. And it actually drives like that on the road, so you really notice when the vehicle hits something and then only increases the power again. I must say, this is because the control unit is so fast and so intelligent that it queries the torque value and says, please give me the power. But the limiter, when it checks again, says, no, I'm not allowed to give you the power. Then that's exactly what happens. The cars actually get worse before the power. So in uncertain matters, I will now set it up properly, then we will do the initial measurement. But as I said, this is just enough so that you have seen how it all works, so that you can really adjust it individually. We also developed the software ourselves here in-house, of course. The flash devices, those we buy, because we can't do everything on our own. But you can see for yourself that we write the software ourselves. Well, then I would say, let's hang around here for another hour or so, and then we'll see each other again at the Bruston, the test bench. We have now done all the initial measurements, so you can see that the brush is quite warm, and the brake here, you can see the temperature has really gone up significantly. There is a Telmo in there, and it's building up a really brutal temperature, so you can see today the weather is really extremely warm, and my hall is heating up quite well. So we'll go to the laptop for a moment. You can see it down here is 33.8 degrees Celsius, which is the value from the test bench's temperature sensor. That's certainly a tough challenge for us today, but it's good. It doesn't stop us from optimizing. I will now briefly explain the initial measurement and show you the individual measurements that we took. I'll now put the measurements out one after the other, just so I can see what a development process looks like. The green curve below, for example, was a basic setting for the power, just so I could see where I end up with the power and then the resulting output power. We took several more measurements, of course, but I've just put a little bit here to show you what it's like. I will send it out to the customer with this final setting. I'll now save the setting in their app in the power optimization section. You can see the torque here again. The brown curve is the one we're actually sending out. So you can see, yes, we now have a full 3000.40 Newton meters of torque and a whopping 780 horsepower. The IKW also responded very well, both in terms of torque and in terms of power. It has a powerful gearbox and a powerful drive. As I said, you can definitely do good things with the power, of course, but the software is always at your own risk. The customer knows exactly if something goes wrong, that's their problem. I've always had that with the front. Very clearly communicated to someone that he wanted to have the power optimization for his vehicle so that he can vary between eco and power again. You can see the torque down here. We now have, let's say in the area here, 3,740 to 3,000, so 2,993, that's almost 750 Newton meters. Clearly it goes forward like crazy. So you can see the torque is held for an incredibly long time. We still have it at 1,800 RPM. Let's take a quick look here. At 1,200 RPM, it's still just under 3,000 Newton meters. That was the maximum here before. So now it has the engine speed in every position. If the customer shifts down or something, he always has full torque from the fuel chip. If you drive sensibly and change the engine speed correctly, the car will still be fun to drive. So it's not like it's going to run out of fuel too much. Of course, if I move around the upper RPM range here and keep turning it up like crazy, then it's clear that it will need more fuel. But if you drive normally, let's say in the area here, down below, the fuel consumption will still be good. Peak performance up here you can see again, but that's again the topic for us. Rather uninteresting, but even so, it can do that. An original also has around 3,700 newtons. It's just as powerful or maybe even a bit more powerful than a HIM, but you know, because of these variable turbochargers, the one down below has a completely different feel. So as I said, it feels brutal on the test bench and you can see it with the temperature. You always have to take a break in between, simply because it heats everything up quite a bit, so that you don't have any temperature problems here either. And also with the tires, because you notice that with that amount of torque, the truck still starts to slip relatively quickly. The wheel basically has no grip. And that's why we tightened the hydraulic cylinder a couple of times, because we still had slippage problems from time to time. Well said, customer. I think he will be very satisfied with it. He can also report back on it. You should drive it for 3 or 4 weeks and see if he really always uses the power optimization, or rather the eco mode. That is then left up to him. And yes, as I said, I am satisfied. You can see that we are doing this with the tuning, that for us too, when things like this happen, it often really has to do with several measurements. You can see the speed from earlier with the whole thing, so that is, again, this individual tuning. But just so that you have a little insight into how something like this actually works in practice, we've reached the end of our video again. The customer now gets the app back as well. As always, our Hugo Boss air freshener is included, which I always add for people. I also briefly explained to him how the app works. Eco power optimization, reading and clearing error memory, because that's how the process works again. So as you can see, he said the mileage is great. It's a really beautiful car, very well maintained, even though it's a construction site vehicle. So for that, it's really still in excellent condition. If you're particularly interested in this fascinating topic of special tuning or special optimization, please feel free to check out our official website at wbb-schaknat.de. As I said, we do more specialized things for certain customers because they want that. Sometimes special things for show trucks, for example. If you are interested in this particular type of special tuning, please feel free to send us an email, give us a call, or send us a WhatsApp message. We would be happy to provide you with individual advice on that. I'm always happy to see how actively you subscribe to our YouTube channel. As always, write in the comments what you like and what you'd like us to cover more in detail. Glad you tuned in again today. Thank you very much. See you next time. Bye.